Good afternoon, everyone from London, and welcome to the Total Transparency when Dealing with Tannery Waste webinar. My name is Martin Ricker, and I am the Content Director of International Leather Maker. Today we have three short but very interesting and topical presentations from three industry-leading experts in their field. All the presentations are very different from one another, but they all fit within the general theme of the webinar and cover some of the valuable work that the global leather industry is doing in developing as well as developed countries to ensure that the leather industry manages its wastewater and materials responsibly and even looks to convert its waste into other valuable byproducts in their own right. Among our audience today, we have attendees from throughout the leather supply chain with a range of knowledge and understanding of this complex topic. Our three presenters have tried to prepare their presentations to reach a broad range of listeners with various levels of knowledge. The webinar today is organised by leather industry media provider International Leather Maker and is in association with the global online raw materials pricing and analysis platform, SAL Report. I'm also pleased to mention the Netherlands-based global leather chemical maker and supplier, Smit & Zoon, as our lead sponsor of the webinar today. ILM could not offer these free events without their support. Just to run through today's webinar program, each of the three presenters will speak for approximately 10 minutes. The broadcast today is being recorded, so we will send a link to all attendees as well as all those that registered but could not access as we were oversubscribed. The first presentation, Chemical Transparency Lifting the Lid, will be presented by Derek Von Beer of Smit & Zoon. The second presentation, Reducing the Pollution Load in Leather Making, a case study for Kanpur, India, will be presented by Ivan Krau, the Industrial Development Officer for UNIDO. And our third presentation, Transparency is Leverage for New Businesses, will be presented by Paolo Gurisati, President of SSIP, the Italian Leather Research Institute. Before I introduce the first presenter, if we have time after the third presentation, we'll have a short 5-minute question and answer session. On your screen, you should see a facility to send a question. Please mention in your text which presenter you would like to respond to your question. Now, I would like to introduce you to the first speaker, which is Derek Von Beer of Smit & Zoon, who will present Chemical Transparency, Lifting the Lid.
Thank you, Martin, for giving me this opportunity of discussing another aspect of transparency, an aspect that is too easily and too often overlooked. It may be common knowledge, but we always need to remember that a product not only leaves its mark on the leather, but also its footprint in the environment. Transparency is actually not the first word that comes to mind when seeing a drained tannery float. Some transparency may ideally be visible when holding a glass filled within, as in completely exhausted float against the light. But what is inside? What is its footprint? There have always been strict requirements, or at least great desires and good intentions, for the quality of the water that flows from the treatment plant into the environment. It's a bit as with children growing up. First we clear their rubbish and tidy up their rooms, no matter how angry we are and no matter what they leave behind. It'll pass, we say, and so it will. When reaching maturity, the crumbs on the table are removed before they fall. The leather industry is now reaching this stage. Today, we see growing focus on what it is that we clean. It's a logic wish and also a need to minimize the effluent load from the start, to prevent pollution and minimize our cleaning efforts in parallel. This presentation is not more than a brief introduction to the approach Smit & Zoon have chosen for making visible the footprint left by the use of their chemicals. But let us start with the water itself. All that we find in the effluent either dissolves in water or it does not dissolve. The soluble part we call TDS, the total dissolved solids. The insoluble one is expressed as TSS, the total suspended solids, and it comprises all those ingredients that have not been dissolved as atoms, elements, or ions. To make it a bit more confusing, Each of the two can either be organic or inorganic. Organic means that the compound contains carbon, and inorganic is simply all that is left because it is not organic. One example of an important parameter is the amount of dissolved oxygen needed for the breakdown of organic matter. This amount is expressed by the COD, the chemical oxygen demand, and by the BOD, which is the biological oxygen demand. The difference between the two is relevant. The COD tells us the total amount of both biodegradable and non-biodegradable organic matter that we find in the effluent. The BOD, on the other hand, says how much of that total organic matter is actually biodegradable. This part we call the BOD to COD ratio. To know the ratio, we divide the BOD value by the COD. And the outcome of this is the percentage of organic matter that can be broken down during biological treatment. Two examples to illustrate it. This float sample has a COD of 5,000 milligram oxygen per liter. The same sample has a BOD of 2,500 milligram oxygen per liter. Divide the one by the other and we have a ratio of 50%. Another float sample has an identical COD of 5,000 milligram oxygen per liter. But its BOD is much lower. It is only 1,000 milligram oxygen per liter. And when we divide the one by the other again, the ratio of this one is 20%. This means that instead of the previous 50%, only 20% of the total pollution can be broken down in the second float. It also means that 80% of it would remain untreated and is discharged as pollutant. Now, contrary to the sometimes expressed belief, low BOD values are not necessarily a good thing. But these are more theoretical examples of fictional products, and we should not get stuck in this place. In the end, we need to turn our attention to our own chemicals. Smith & Sohn has studied its fat lickers and retanning agents for the environmental aspects of their daily use. And what we found has been collected and published in the Product Passport. The Product Passport contains information on all that needs to be known about our product. Today, this means that transparency is required not only for haptic effects and performance properties, but that detailed knowledge is shared on the environmental characteristics too. This Product Passport combines the effects of wet end chemicals on leather and on the effluent. For each product, a breakdown of the most common environmental parameters is given with the values of their residue in the drained floats. One good example of what these figures can tell us is demonstrated in this graph. Again, we turn back to what we just discussed. It's about the COD and the BOD. On the bottom, we see numbers, and these numbers represent a random selection of fat lickers listed in descending order of COD. You see the lines going on the left from high to low towards the right. That's the blue line. Below that line, we find at differing distances the BOD values. Here, a large gap between COD and BOD indicates a high pollution of very doubtful biodegradability. And here, we see an example of close proximity between the two. And this indicates a very high biodegradability of the pollutant. Now have a look to the values on the left. Perhaps you wonder why they are sometimes rather high and where they come from. For the Product Passport, not only the drained floats of the actual process have been measured, but the contents of the subsequent washing floats too. In other words, not just the float after fixation, but also the floats for washing afterwards. Here we see to what extent this final process step can reverse the previous fixation of the chemicals. We can even say to what extent we can reverse the seemingly good fixation of the chemicals. The black part represents the residue from the acidified fat liquor bath, and the blue part shows how much in addition is being released during washing. I think it's easy to see. Sometimes it's 50% or even more, which is released through washing. I hope that this brief outline has given you some fresh insights in the nature of the so easily overlooked discharge process floats. Because these floats are hidden between wet end processes and the water treatment later on. While these floats are still part of the wet end process, we should leave them alone and let them do their work. And once they are blended inside the big collecting basin of the treatment, we lose sight of their individual nature and contents. But the whole is made of its parts, and it's our belief that we can only understand the whole if we know what these parts are made of. So let us lift the lid together. And I thank you for your attention.
Thank you, Dirk. That was most interesting. I would now like to hand over the webinar to our second presenter, Ivan Král of UNIDO, who will talk about some of the great work that has been going on in the Kanpur leather cluster in India.
Good afternoon, and thank you for a very interesting presentation made by Dirk. My name is Ivan Král, and I will present the project in Kanpur, which will complement the presentation made by Dirk. This will show how environmental footprint can be reduced, including COD, BOD, TDS and TSS, and the importance of transparency and proper communication. Kanpur is the leather cluster within Uttar Pradesh on the bank of a Ganges river near Lucknow. The leather industry is an important export earner, and it is well known especially for saddlery products. Unfortunately, Kanpur is also famous for being among top 10 polluted cities. Not surprisingly, leather manufacturing is considered as major source of pollution by Uttar Pradesh government. Yet, leather units, according to some reports, contributes only 8% of the effluents. Leather industry, as we know, is an easy target and scapegoat. We have to admit that existing common effluent treatment plants don't comply with all standards due to various reasons. In order to protect Ganges River and to reduce pollution within Kanpur, there is a need to improve environmental performance of leather units and tanneries and CTPs. The Kanpur leather clusters contributes to approximately 1/3 of India's leather export. There are around 400 registered tanneries. However, recently, National Green Tribunal ordered approximately 100 units to close down. On top of that, Uttar Pradesh Chief Minister wants to shift out of the Kanpur. It gives uncertainty for the whole sector development, investment, and employment. Tanneries operating within 3 clusters, Jajmal, Bantur, and Unnao, are a mixture of well-organized and modern tanneries with own pretreatment and treatment facilities. These tanneries comply with all relevant standards. However, there are many small production units which are unable to fully comply with standards. They discharge effluents to common effluent treatment plants, and the solid waste is produced by tanneries are partly processed or landfill. However, in some cases, solid waste is converted in units which are not really up to date. In order to improve the current situation and assist the leather industry, UNIDO jointly with Uttar Pradesh Leather Industry Association and Government of India prepared a program to cover the 3 most important elements of sustainability. It means community, workers, and consumers and end users. And how it is achieved? For community, it is reduction of pollution from tanneries and implementation technically viable options to protect environment. For workers, it is improvement of safety and working conditions, which should lead to reduction of accidents and tragedies. And for end users, it is elimination of restricted substances and improvement of product designs to make products safer for consumers. For all this is needed also transparency, and for achieving of this goal is especially industry needs to avoid to prevent negative news. It is needed properly communicate strategy and also actions related to improvement of environmental performance, safety standards in tanneries. However, proper and accurate reporting is needed from both sides. From industry, we should not hide problems, rather to resolve them. On the other hand, media and NGOs should not attack leather industry as the whole sector, only those who are not complying. Otherwise, also good companies and tanneries are hostages of this situation. As practical part of the project, several demonstration units were installed for hands-on training in tanneries. As example, hair-saving units, fresh hides processing, mechanical desalting, water management and conservation and mixing, lime recycling, solar water heating, solar air heating, for flashing water control and safety demonstrations and safety trainings. As an example of solar air heating, that's something what we prepared within climate conditions in Kanpur. Solar energy is an attractive option to reduce carbon footprint. Heated air is used for drying after finishing and spraying. Installed unit reduces approximately 100 tons of CO2 per year, and payback period is approximately 4 years in this case. Total dissolved solids is considered among major problems and pollutants in India, but also all around the world. Processing of fresh hides is an alternative which will reduce level of TDS in wastewater. It is hoped that also in Kanpur, regular production will start soon. Although in this chart is over a reduction of pollution from all demonstration units, we can assume and we can also confirm that use of proposed technologies will also reduce pollution load in CETPs and will improve performance of CETPs. Practical demonstration was only one part of the training. Other part of the project focused on practical and theoretical use of innovative approach in training. In order to improve quality of the training, blended course was prepared, which was mixture of e-learning, mix of media use, animated training tools, and the hands-on training. This training was prepared in cooperation with University of Northampton and Kanpur Leather Company, which was host of this training. Due to many accidents involving also hydrogen sulfide, specific training on hydrogen sulfide was implemented also in Kanpur. For last year, no accident with hydrogen sulfide was reported in Kanpur. Other training courses covers also sustainable leather manufacture, first aid at the working place, working at height, leather testing, and others. Although there is a genuine interest to improve the current situation, there are many factors outside of industry control. Although a lot has been done so far, still there are issues which needs to be addressed. I would like to thank for your attention, and this picture also shows commitment from one tannery located in Kanpur to make leather industry really green. For more details about project achievements, you can also find it in January issue of ILM. Thank you very much.
Thank you, Ivan. Work around the Kanpur leather cluster is an ongoing process, but it's really encouraging that UNIDO and its partners are offering local tanners information on the best available techniques and important training programs. I would now like to hand over the webinar to our third and final presenter, Paolo Gurisati from SSIP, the Italian Leather Research Institute based in Naples. Paolo will focus more on some of the work that he has been involved with in Italy.
I want to present myself as an industrial economist, in this moment president of SSIP, the Italian Leather Research Institute. I'd like to propose you another perspective on transparency as an opportunity more than an issue. Transparency as a leverage for new businesses. I can see three driving forces in this direction. The first one is that transparency is highly required today by wastewater treatment authorities. They have two main concerns. First of all, to avoid the presence of polluting molecules, of course, and secondly, the reduction of organic sludge and safe gasification of the sludge if possible. A second force is connected to transparency is coming from by clients. LWG, the Leather Working Group, EPD, Environmental Product Declaration, and the Zero Discharge of Hazardous Chemicals organization are forcing leather producers to certify chemicals contained in products and processes. There is a great discussion today about the method to be used on this side, but the force is quite strong on our companies. Third, transparency is a basic condition today for exploiting the potential of new technologies for organic waste transformation in new products, byproducts, recycled raw materials suited to commercialization. So let's have a closer look to each one of these forces. The first one, wastewater treatment challenges. Traditional treatments, chemical, physical, and biological, face today new problems in reducing metal molecules and what we call recalcitrant COD, mainly when wet blue and wet white flow together, or the wastewater of wet white and wet blue flow together in the same sewage collection system. Today, ozonization processes, activated carbons, and membrane treatments are applied at the end of the depuration system in order to reduce wastewater to the rivers, but they fail in segregating polluted molecules beyond the higher consumption of energy that they are producing. So the perspective of early selection of specific pollutants in innovative sewage collection systems and the introduction of new treatment technologies prior to existing plants drive to smarter and automatic control system, what we call Industry 4.0 perspective. Let's see the sector force in deep environment-friendly social needs rising from the market. Leading trade organizations, mainly in the fashion system today, encourage the claim for safe and environmental-friendly products. Zero discharge of hazardous chemicals as a volunteer agreement among producers and distributors may be considered a scaffolding structure of a new market system, more sustainable, that is rising up today. LWG, EPD, and other certification processes force leather producers and chiefly chemicals developers to construct a transparent value chain in order to reduce technical and commercial conflicts. A great discussion has been launched recently among technical experts and laboratories participating to the DHC in order to approve efficient methods. Testing on textile are different from testing on leather. So we have in front of us a narrow path to follow, that is tracking and tracing methods and smart technologies facilitate the separation of proteins and other organic materials or valuable input for new biochemical and biotechnology processes. However, specific regulations, or better, the absence of a specific knowledge and regulation framework on substances of animal origin, complicate the legal framework of the leather waste material transformation, even though investment potential and commercial interest are rising. So new products, byproducts, and recycled raw materials need to be certified as a non-waste material in the circular economy market system. And this perspective requires new methods for continuous checking of the composition processes. And now we can have a look at 3 examples of what I mean for new businesses or new processes coming at the end of the leather production cycle. First of all, biostimulants, for example, for intelligent agriculture. These compounds come out hydrolyzing processes transforming shaving powder in innovative materials that carry no traces of dangerous contaminants. Or, for example, bioplastics and biogas produced thanks to advanced technologies are materials completely different from the original input, waste or sludge. Keratins at the end, proteins, recovered by hair thanks to advanced extraction processes, do not contain any trace of the original cattle organic features, diseases, or DNA structures. What we have in mind is a perspective of a new framework for developing a new perspective of leather as a sustainable and transparent business. So this is just a picture for describing a reactor that is producing bioplastics, PHA. Just an example for giving you an idea of what techniques we have to use. And summarizing at the end of this brief presentation, the argument we are going towards new technology and legal framework in order to exploit this perspective of new businesses, thanks to transparency. When recycled materials, even of animal origin, are transformed with advanced biotech and biochemical processes, they can be classified as non-waste products or raw materials good for the circular economy applications. The development of a transparent technical and commercial value chain is highly dependent by an advanced regulation system that we have to design, providing investors and consumers with detailed information and knowledge about new products and compounds. So this is the perspective I wanted to share with you, and I thank you very much, all of you, for attention.
Thank you, Paolo. You covered some interesting topics within your presentation today, and leather certainly has the potential to fit well within the circular economic cycle, as it comes from a natural raw material, which itself is a byproduct of the meat industry. At this point, we were going to do a question and answer session, but there aren't any questions from any of the listeners at the moment. So what I would suggest to do, if you want to send a question to me at my email address after the event, then I'd be happy to forward it on to any of our presenters, and they can obviously email you back directly with any questions. Firstly, I'd like to thank our three presenters for taking the time to present today. We covered a lot of ground in a very short space of time. I'd also like to acknowledge our sponsor, Smith & Zoon, and my ILM colleagues who are working behind the scenes to make the webinar as smooth as possible today. We will send you all a short survey after the webinar, and you can tell us what you thought of it. ILM will be organising more free webinars later on in the year, so keep an eye out on our website, internationalleathermaker.com. Finally, I would like to thank you all for tuning in and listening to the webinar today. Goodbye.